Now we're going to look at how we go about writing and graphing a linear function. And this should be very familiar to you. It's going to look a little different because we're using the function notation, but it's very similar to what we did with writing the equation for a linear equation. And we have the following. It says write the linear function f such that it has the indicated function values. So they tell us f of negative 3 equals negative 8 and f of 1 equals 2. Now, what I really want to emphasize is what does that mean? Well, that means when x is a negative 3, y is a negative 8. So basically, when you see this notation, that means that we have the point negative 3, negative 8. Just like f of 1 equals 2 means when x is 1, y is 2. So that's your point. X is 1, y is 2. So if we want to write the linear function, then that's the same thing as writing the linear equation. So we could use the point and the slope. So that's where we can use, if you recall, we can use y minus y1 equals m times x minus x1, or we can use y equals mx plus b. So either one of those. And if we're using either one of these, we need to know, of course, the slope m, and then we need to know a point. Well, we're given the point. We actually have 2 points, so we need to actually find the slope. Well, we can find the slope, and our slope formula is y2 minus y1 over x2 minus x1. And we can label these points either way, but I'm going to call this one x1, y1. This would be x2, y2 then. So our slope would be 2 minus a negative 8 over 1 minus a negative 3. Now be careful with your minus signs here. So 2 minus a negative 8, we would end up with 2 plus 8, which is 10. 1 minus a negative 3 is 1 plus 3, which is 4. And 10 over 4 we can divide by 2 and reduce to 5 halves. So now I'm going to use the y equals mx plus b, and I'm going to use, and it doesn't matter which point, you could use negative 3, negative 8, just so I don't have to have the negatives. I'm going to use the other point here, 1 and 2. So if I plug into here, my y value is 2, so I would get 2 equals the slope 5 halves times our x value, which is 1, plus b is which we're trying to solve for. So then we have 2 equals 5 halves plus b, and if we subtract 5 halves from 2, well, this is really 2 1/2, so 2 minus 2 1/2 would be left with a negative 1/2. So then we would have y equals our slope of 5 halves x minus 1/2. So there is the equation of our function. So if we look at the graph of this, and of course if you want to write it in the function notation, we could write this as f of x equals 5 half x minus 1/2. So you could write this either way. And if we wanted to look at the graph, we could certainly use the calculator, or I'm just going to do a rough sketch here by hand. We know that the y-intercept is a negative 1/2, so if this is 1, we would be here at a negative 1/2, and then our slope is 5 over 2. So if we count up, let's see, it'd be 1, 2, 3, 4, 5, and then we would go over 2, and then our line would look something like this. So that would be the graph of our function 5 halves x minus 1/2. And again, we can kind of verify we did this correctly. Our slope is positive and our line is going up to the right as we go from left to right. All right, so here we have another example, and maybe you want to pause the video to see if you can work this one out on your own. We want to come up with the equation and look at the graph for the indicated function values. All right, once again, we have f of negative 5 equals negative 1, so that means we have the point negative 5 comma negative 1, and f of 5 equals negative 1, so that means we have the point 5 comma negative 1. Now at this point you may notice something about these points, but I'm not going to point it out just yet. We're going to go ahead and find the slope, and again this would be our x1, y1, x2, y2, so we have a negative 1 minus a negative 1 over 5 minus a negative 5. And here, what do we notice is going to happen? When we subtract negative 1 plus 1 on top, that goes to 0. And on the bottom, we get 5 minus a negative 5 is 10. So our slope turns out to be 0. And if we know our slope is 0, then we know we must have a horizontal line. And if we have a horizontal line, the equation for a horizontal line is always y equals some number. And in this case, because our points both have a y value of negative 1, it must be y equals negative 1. So there is the equation. And of course, if we were to look at the graph, we know that we would go to y is a negative 1, and we would simply have a horizontal line. Now, right from the beginning, we could have determined that we had a horizontal line, because if we would have looked at our points, both of these points have the same y value of negative 1. Or we could look up here. Both of these have the same y value of negative 1. So that means if we're looking at a straight line, then it must be horizontal. So if you notice that, then you really would not have had to have gone through finding the slope. We would have already known it was a horizontal line, and it would simply be y equals negative 1. All right, I do want to finish up this video with looking at an example of how to evaluate the step function at different values. And I want to do this because I know this is probably still somewhat new to some of you. We have our function h of x equals x plus 3. And keep in mind, again, on the quizzes in Blackboard or sometimes in your book, if you see these double bars like this, looks more like absolute value, but you have two of them, this is indicating this greatest integer function here, which is again called a step function. So if we want to evaluate this function here, it says we have the x plus 3 and it's inside of our greatest integer here. So that means we're looking at h of negative 2 equals, and I'll just use these double bars here to make it easier to write, we would have negative 2 plus 3. Now, before we perform the operation, we need to do what's inside of here first. So that means negative 2 plus 3, that's going to simply be equal to what? Well, negative 2 plus 3 is going to be 1. And then if we look at the greatest integer here, that means, is this number an integer? Well, the answer is yes. Because this is an integer, then that will be the answer. So the answer is simply 1. Now, if we look at the next function, we have h of 1/2. So if we plug that in, we would have 1/2 plus 3. Okay. Now again, before we perform the operation, we want to add these together. So 1/2 plus 3, we could simply write as 3.5, or we could write it as 3.5. And if we have 3.5, is 3.5 an integer? And the answer is no. So therefore, we need to look at the greatest integer that is less than 3.5. And that would simply be 3. All right, and our next example, we have 4.2. So here we're going to look at 4.2 plus 3. So if we add this, we're going to end up with 7.2. Is 7.2 an integer? Well, the answer is no. So what is the next integer below 7.2? And that would be 7. So hopefully you're starting to get the hang of this. It's really easy once you realize what you're looking for. And the last one we have negative 21.6 plus 3. So if we have a negative 21.6 plus 3, then we're going to end up with a negative 18.6. And this again is not an integer, so we want to look at the integer that is less than a negative 18.6. And be careful, you may want to think of your number line and think of it this way and say, well, here's a negative 18.6. So that means this is a negative 18 over here, and over here we'd have a negative 19. And if we're going less than 18.6, then that means we need to go down here. So the answer is a negative 19. All right, so there are some examples of evaluating this greatest integer function or this particular step function, and how we can go about writing the linear function f given the indicated function values. So keep in mind when you have this function type notation, you're really just given the points x and y. F of negative 3 equals negative 8. That just simply means when x is negative 3, y is negative 8. When x is 1, y is 2. So that is the great thing about function notation. It actually gives you the point on that particular graph.